See this? If capital A, B and C are three non-singular conformable matrices for multiplication, which means we can multiply them all the three, then prove that ABC inverse equal to C inverse into B inverse into A inverse. So I have taken this question just to tell you that earlier we have seen it for two matrices. I just wanted to say that even if you have n matrices, a chain of n matrices, all of them are multiplied and then take an inverse, then the reversal rule applies even for n matrices. We have already shown it for two matrices. So what I mean to say is, we have already earlier given the proof that AB inverse equal to B inverse into A inverse. This one we already did it, right? And I have also given you the proof. Now using this, just product of two matrices, I am just extending it. If you can understand this extension, we can do it even for n matrices also. So what you can do is, you just divide this into two as if it is a product of two matrices. Okay, so I am just dividing it as if it is a product of two matrices, and I have taken inverse. Now we have only two matrices, right? So this is first matrix and this is second matrix. Now apply the reversal rule. What is it? Take the inverse of the second matrix and then multiply with the inverse of the first matrix. So take the inverse of the second matrix and then multiply with the first one. Or even you can divide it in the other way. You can divide it as if it is A into BC. A should be the first matrix and BC should be the second matrix. That way also you can do it. Whatever it is, you just see that you are writing it as if it is a product of two matrices. That equal to, now you can again write it like this. This one is B inverse into A inverse, right? So you can even extend it for n matrices. You can even see how it works for ABCD. ABCD whole inverse equal to, you can write it like this: ABC into D whole inverse, right? And now you can write it as if it is D inverse into ABC inverse. And just now we have shown that ABC inverse is C inverse into B inverse into A inverse. That is why you can write D inverse into C inverse into B inverse into A inverse, right? So again we got it, see the reversal ABCD, right? So we can extend it even for n matrices. It's very important. Just remember this way. If you have a product of n matrices and if you want to take the inverse of it, you just take the inverses of the individual matrices and then write them in the reverse order. It is just the reversing rule. Okay, and the same thing, the same way we can even apply it for the transposing also. We already seen that transposing. Even if you replace that inverse with transpose, all of them will apply. Okay. See the next one. If product of two non-zero square matrices is a zero matrix, then show that both of them must be singular matrices. So what they mean to say is, if we have two matrices A and B in such a way that A is not equal to null and B is not equal to null, which means these are non-zero matrices, but the product of them is null. Okay, and now they are saying that if the product of two non-zero square matrices is a zero matrix, then show that both of them must be singular. Both of them must be singular means, then we should show that det A equal to 0 and det B equal to 0. So this is given. So given is this, which means they two are non-zero but the product is 0. That is what is given. Now we are supposed to show that this one and this one, that det A equal to 0 and det B equal to 0. We are supposed to show that both are singular matrices. So I'll try to prove it by contradiction. Contradiction means I'll assume that it is 0, then I'll show that it cannot be 0. Okay, so first I'll assume that it is just an assumption. Assume that det A is not equal to 0. What does it mean? That A is non-singular. Whenever A is non-singular, we know that inverse exists. So what does it mean? A inverse exists, right? So now we already know that A into B equal to null, zero matrix. See, when I write like this, it is not 0, it is 0 matrix. It is n by n matrix containing n square zeros in it. Okay, now I'll take this and I'll multiply pre-multiplication, which means multiplication from left hand side. I am going to multiply with this A inverse, since A inverse already exists, right? then what do we get? A into A inverse is I. Then I into B equal to A into A inverse into 0. Anything that you multiply with 0, 0 matrix is going to become 0. So it is 0. So what does that imply? B equal to 0, which is a contradiction because we already know that B is not equal to 0 and A is not equal to 0, which means B is not equal to 0 matrix and A is not equal to 0 matrix. By assuming that that A is not equal to 0, we are able to prove that B is a 0 matrix, but it is already known that B is not a 0 matrix. Therefore, our assumption must be wrong. So then what is wrong? That A is not equal to 0 is wrong. Then what must be right? A is equal to that A equal to 0. So what does it mean? It means that A is 0 and A is singular. So A is singular is shown. On the same grounds, exactly the same way, we can even prove that this one is also true. So how? Again the same method. Assume that B not equal to 0, which means B is non-singular. When B is non-singular, then B inverse exists. B inverse exists. Right? Now since B inverse exists, what we can do is A into B equal to null. We already have this. Multiply both sides with B inverse from the right hand side. That is called post multiplication. Now A into B inverse equal to 0 into B inverse. That implies A into I. B into B inverse is I equal to 0. 0 when null matrix is multiplied with any matrix, you are going to get 0 null matrix, right? So what does that mean? A into I is A. That means that A equal to null matrix. But we already know that A is not null matrix. So by using this assumption, what is the assumption? That B is non-singular. By using this assumption, we have shown this one. But since this is false, this must be false. Then what is true? That B is non-singular. Therefore, both A and B must be non-singular. So that is the proof for the second one. Okay. Fine. Using this point again, we are going to see one more example, the next example. So that is why this proof is important. From this proof, we shall prove some other thing. Okay.
Hi. If you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. and these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.